Hello, welcome back. This is problem number 24 in this AP Physics C mechanics multiple choice test. So there's a scenario associated with this set of three problems, 24 through 26. This scenario goes, two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speeds of v1 and v2. Their orbital radii are r1 and r2 respectively. Assume that m is much larger than mass 2, which is larger than mass 1. And problem 24 asks us, the ratio of speed v1 to v2 is a root r2 over r1, b root r1 over r2, c root m2 over m1, d root m2 over m. Oh, a typo by me. This should be a 1. This should be a 2. And e1. So what this problem is asking us to deal with is 1, the gravitational force, and 2, centripetal force. So the way we're gonna set up this equation is we're gonna have an equation for v. We're gonna have an equation that has v1 in it. Another equation that deals with the other particle, m2, which is gonna have v2 in it, and then we're gonna simplify each and then divide once we've isolated v1, and that is going to give us the ratio. Alright, so let's start with our equation that has v1 in it. So what we're going to do is we're going to set up an equation for the force on m1. So the way we're going to do this is first we're going to use centripetal force or centripetal acceleration. So in this case, we're going to use centripetal force, just multiply the mass into it. This is going to look like mass 1 times velocity 1 squared over r. So here's our centripetal force is equal to the gravitational force. All this equation is going to be saying is that the force pulling these satellites in is gravity. So our equation for gravitational force is g, the gravitational constant, times m1 times m of the source of that gravity, which in this case is going to be our planet, and then all of this over r squared. And in both of these cases, since we're talking about m1, it's going to be r1. And this is r1 squared, yes. Alright, so once here, there's a couple things we can cancel out. Let's get rid of m1. Let's get rid of r1 and this square from the denominator. So now what we have is v1 squared is equal to g times the mass of the planet over r1. Alright, from here, let's move over. Leave this for now. We're going to come back to it. Let's go to solving for v2 squared. So let's set this up the exact same way. We're going to have, first we're going to represent the centripetal force on mass 2. So that's going to be m2 v2 squared over r2 is equal to the gravitational constant times mass 2 times the mass of the source of gravity, which is the planet, all over r2 squared. Again, we're going to be able to cancel out the masses from each of these, radius on the denominator here and the square here, which leaves us with v2 squared is equal to g times g, the gravitational constant, times the mass of the planet over r squared. Over r2, the radius of the second satellite. So once here, we are going to do as the problem asks and divide v1 by v2. So an equivalent form of v1, or a way we can write this is we're going to go ahead and say v1 over v2 quantity squared this is equivalent, so we're allowed to do this. So it's going to be this, and then what is this going to equal? Well, it's going to equal what we have for V1, GMP. Well, actually, before we write this out, there's another thing we can cancel out. So this is a constant, and this is also a constant, because the gravitational constant, by definition, that's a constant, and the mass of the planet is going to remain constant. So this does not matter. These are constants here. So now we can represent V1. V1 is going to, or the other side of the equation, we're going to have 1 over R, 1 over R1, divided by V2, or V2 squared. V2 squared is 1 over R2. So this is equivalent. We can, dividing is multiplying by the reciprocal, so we can say 1 over R1 times R2 over 1 is equal to R2 over R1, and then I'm going to rewrite this in this tiny little space over here. Totally ran out of space. I'll bring the computer closer in a minute to make this a little bit more visible. What we're going to do now is we're going to take the square root. So I'm just going to write my answer here but show you the work over here. So we're going to take the root of this over the root of this, which is going to say V1 over V2 is equal to root, this 2 shouldn't, is equal to root R2 over R1, and that is our answer, root R2 over R1. That's going to be A. Let's bring this in a little closer. There's our answer in the middle of the page on the right. So this is a pretty hard problem. This set of 3 are 3 of the hardest problems on the test. So if you made it through this far and you understand this, that's wonderful. That's good news. So again, what we do here is we're representing the force. We're saying this is the gravitational force. We're saying this force is a centripetal force. We're setting the centripetal force equal to the gravitational force. We're isolating V1 squared and V2 squared, and then we're dividing using putting them both inside the square, our exponent rules, and then we're dividing, and from there we can isolate the answer. Thank you for watching. Let me know if you have any questions about this video, about gravitational force, about centripetal force, and make sure to check back in for question 25.